Hey everybody, and welcome back. Today we're going to be learning how to run a model or one of our simulations multiple times in a row and kind of learn how to look at those results and be able to analyze those. So what we've done in the past has been a lot of, we get our data, we run it through either a random forest regression, a decision tree, or even for the unsupervised learning, the clustering algorithms, right? We run it one time, and that's what we have. That's our prediction. I've had a lot of people asking me about things like Monte Carlo simulations and working with just kind of a bigger database and getting more data and all sorts of different things. So this is going to be the first step in taking a lot of the basics that we've been doing and working into more of a quote-unquote like professional iteration of it. So we're going to do a little bit of that today. We're going to be using our same data set. So it'll be stuff that you should already have or something roughly equivalent to if you've been using your own data. But yeah, that's what we're going to hit today. So let's jump on it. First things first, we're not really going to have any surprises up front. We're going to run through, we're going to be importing the same modules that we've been doing for our random forest regression analytics. We're using our sample data for YouTube data set here. If we take a look at that, just as a quick refresher, we have player name, the game, the date, fantasy points they scored, and their rolling averages for the last 3, 5, and 7 games, and their overall season average up to that point. So that's what we're going to be working with. This is for the 2019-2020 season. Again, we're not going to be using anything new until we kind of have a system laid out, and then we'll work on how to pull stats on a regular basis, how to keep it updated on our end, and all of that fun stuff at a later date. But for now, the static data set's perfectly fine to go over the concepts. So as is good practice, when we get a data set, we want to check and see what kind of data we have. As we can see, to no surprise, player and match up are objects, which for pandas, basically we're looking at it as like a string, right? It's not numerical, it's not a date time, it's just an object or a string, a non-numerical object. Or at least that's how it's reading it. If you get this and you see, like if it was reading season average as an object instead of a float, we would then need to do some data cleanup and either cast it as a float or figure out why it can't automatically read that as a float. So no issue there. Game date's already a date time format, that's phenomenal. We're going to drop the matchup and the game date because we don't really need either of those for what we're doing. And we're going to set the index to the player, so it moves from being a data column to our index that everything runs against. And just so you can kind of see what that looks like here, again, player is now our index, and then last 3, 5, 7 season average and the fantasy points they scored. You'll notice we have moved the column order around a little bit. Fantasy points is now at the end. We did that here by defining it as the last column in our data frame. Relatively simple stuff we've all gone over before, just running through this quick. So to be able to run this through our random forest algorithm here, we need to define our features and our labels. Remember, our features are going to be the actual data points that we want to use to predict our labels. Okay, so feature names, it's going to be last 3, 5, 7, and season average. Those are the data points we're using. And then our label, or what we are looking to predict, is going to be our fantasy points. So we're going to go ahead and do that. We're going to run, and we see our DF features now is just the player name as the index. That's not a data point. And then our average is here. And we're going to run for the labels, and now we can see we have the player name and the fantasy points that they actually scored in that game. So next thing up, and again we've done all of this before, is just converting those into NumPy arrays. And then we're going to split our data set into a training data set and a testing data set. So our train, test, train labels, test labels equals, we're using the train test split function here. Features, labels, our test size, remember we're defining how much of our data set we are kind of sequestering away for the model not to be able to see until after it's been trained. So typically what we do is we would train a data set and then run our test data through that trained data set and see how accurate it is. Because it's going to be very accurate with the testing data, because that's what it's learning, that's what it's iterating over to learn. But the testing data, it's never seen before. So that's kind of that's what you're going to use generally to judge the accuracy. We're not going to be doing that today because that's not the point of this. And we are defining a random state of 0 for that training. We're going to go ahead and define a random forest regression object here. We're going to fit it to our training data, And instead of predicting it over the testing features, just that small subset of the data for testing purposes, we're going to run it over the entire features data set. And that is going to give us an artificially accurate algorithm here, because we're factoring in, 60% of that features data set it's already learned on and been tested. But that is just, saying that to get it out of the way so no one thinks that we've, discovered the greatest algorithm ever here. So what we're doing is we are getting predictions off of that feature data, which again is going to be this, right? So we're feeding these data points in for this entire data set, all 14,397 entries, and we are predicting the fantasy points for each of those instances. So what I've done here is we've just defined a new data frame. It's just going to be data set with the fantasy point column, so that's just going to be the player name and the fantasy points they scored. We're going to be adding a column to that is going to be predicted, and we're going to be feeding in our actual predictions to that column. And then we're going to be calculating an error column, which is going to be the absolute value of the difference between what we predicted and what happened in reality. And if we take a look at that, we can see that it is remarkably accurate. Our average error is only 3.3 points with a relatively small standard deviation of 3.9. For those of you that don't remember our standard deviation lessons, what that essentially means is that 68% of all of the data will theoretically fall within one standard deviation of each side of the mean. Fortunately, this is an unnecessarily accurate data set because we are again predicting over our test data, which in real life you would never do. We would classify this as an overfit model, and we move on. So if we look at our data frame here, we described it here to kind of get the averages and numbers. If we actually look, we can see for Abdel Nader we predicted 16, it was 19. Got that pretty much right on the money. Pretty close on the money, on the money, on the money. So that looks very good. However, if we want to check if we look at the high scoring players, and again, like, these are the games that can really set you apart. You're going to have two scenarios in which your model is going to really thrive. If you can accurately predict the outliers, single games, for the ultra high scoring players, like if you happen to have LeBron the night he goes for 88, there's a pretty good chance that you're going to be winning some money that night. Or if you happen to have the role player that pops off that night, you pretty much need to have those two scenarios working for you to have a very good chance at winning some good money. And as you can see, our errors get significantly higher with these guys. DeAndre, and the ones that are remarkably low, I would bet large amounts of money were in our training data set, and that's why it's so accurate. But it's neither here nor there. Just wanted to reiterate, this is not a good model. This is not a good data set. This is just an example that's easy to understand. So how do we run that a bunch of times and take the average of all of our predictions? Which again, the random forest is already kind of doing, but it's, it'll make a certain number of forests and it'll calculate it out and it gives you the weighted average for that one, but maybe we want more than that. Or maybe we want to take some combination, right? So maybe we run just a statistical analysis on the player's performance and their matchup. We say they have a really good matchup, so now we want to look, say, okay, well, I know it's predicting this, but they have a really good matchup. I feel really good about it. I want to take the 75th percentile of their predicted scores. So we don't want to just take the average. We want to take the higher end of their averages or higher end of their predictions. Those are the types of things that this will open the window to. And to do that, it's not going to be terribly difficult. And there probably is a better way to do this using an existing Monte Carlo module, like we're using scikit-learn here for the random forest. There is probably a Monte Carlo simulation option that you can import as well. I'm not familiar with that, but at its core, a Monte Carlo simulation is just going to run the simulation over and 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 over again, right? That way you get a wide breadth of outcomes and you can figure out, get a better idea of what the most likely outcome is going to be. or how far from likely, I guess, the outcome you're looking for would be. So we're going to create a new data frame called compare_df, and we're just going to make a copy of our initial data set data frame, and then we're just going to run this one for 10 times. What we're going to do, because we're going to use the same data, we're going to use the same 60-40 split, so the only thing we're going to really change is going to be the random state of which we train and run our regression algorithm at. So what I'm going to do is for I in range 0 to 10, n equals random.randint, and the random module is something we import that is built into Python. You don't need to pip install anything for that. You can just import random. We're going to import random, and we are going to get a random integer between 0 and 100, okay? For each of these. So theoretically, all 10 of them would have a different one. Not necessarily guaranteed. You could randomly get the same integer twice, but in theory, we're getting 10 different random states to use. And then we're going to do our same thing normally, but we're now going to be using the variable n, that random integer, for the random state here, and we're going to be using it for the random state in our regression algorithm. Okay, and then we're going to do the same thing. We're going to fit it, we're going to train it, we're going to fit it. We don't need that. Well, that didn't need to be there. So we're going to fit it. We are going to get predictions again over the entire feature data set. And again, we are testing, or we are training on 60% of this, so it might be a little too accurate and not realistic, but this is what you would do. You do this, and instead of running it over the same data set, you would run predictions on your other data set that would be set up in the same format you trained on. It would just be, you know, for the players for today, rather than the whole data set of box scores. So you still train on that. You just don't actually get your predictions. You feed in your new data set for your predictions. Now we're going to do compare_df. We're going to add in, because we already have data set, so we're going to add in the prediction and feed that in there. We take a look. This is going to take, I don't know, a minute or two to run, not too long. So, okay. So now we look at our data frame head, and it looks like we left in the last 357 average. That's fine. So now we can see 19.3 is what Abdelnader actually scored in that game. Our predictions are 16, 10, 9, 16.5, 16, 15, 9, 16.5, 16, 9. So not too far. A little bit under predicting, but not terrible. We look at Brad Wanamaker. He scored 16.7. We got 14, 17, 17. All right, so that was a little bit closer. 46. Not bad. 25, not bad. 36, not bad. What about, we look at the tail? Still good. All right, let us go. Okay, now we're just going to do the same thing again. I mean, we're going to be doing a new run of random integers. We're just going to be doing it to calculate the error rather than to just show the predictions here. We're going to do that, so we're going to create a new error data frame, create a copy of our data set, running the exact same thing again. We still don't need that, don't know why that's there. Except this time we're going to do the error, which is be the absolute value of the predictions minus our fantasy points cast as an integer. So go ahead and run that, and it's going to run through its 10 times again. We take a look at that. Okay, our errors, whoa, zeros, all right. But again, we cast these as integers, so, you know, it's not saying it guessed exactly 16.7, but it was less than 1 point of a difference. We can see they're looking pretty good. Now let's look at the describe function, because that's actually going to show us, you know, what the average error was. Because if we did that up here, just showed like the average prediction across each model run, and that really doesn't give us much. If it was by player, sure, but right now it's not. So we'll do now have error df describe, and as we can see, our average errors are going to be pretty low still, like the 3.36, right? Standard deviation 9, 13. So this one, oh, that's the fantasy points. Never mind. Yeah. So they're all very, very close together, with the maximum error 32, 39, 37, 38, 40, 40. Okay. Yeah. So pretty similar to what we had before. Not a huge deal. And I think it's good good practice to just check your feature importances and make sure this checks out. It's not a big deal here because this isn't like a real data set or model that we want to use. But in general, you'd want to take a look and just kind of make sure that this jives with what makes sense to you. Because it's very easy. I did it several times putting this together and putting the previous videos together. You accidentally let like fantasy points slide through or something like that without realizing it. And suddenly, it's an amazing model. It's so good at predicting. Well, that's because you're feeding in the points already, and it's looking to solve for the points, so it already has it. Or a lot of times, you got to be careful. If you feed in like box score data, if you feed in the points, the rebounds, the turnovers, the steals, the assists, it's probably going to figure out, the combination of those that feed into the fantasy point score, so it'll be very accurate. But when you're looking to predict, you don't have the box score, right? So you can't use that. So it would be a bad thing to have anyways, but just be careful. It's easy to accidentally let something slip through into your model that is going to make it either really good or really bad without you really knowing why. So this is an important step. All right. And then we're going to do something else real quick. Just since I mentioned it, we are going to look at a describe function. We're going to transpose our compare df data frame, which is this guy up here. And then, so that's going to put our players across the top and our models down the bottom. So that way we'll be able to see the stats for the players themselves, right? Here we go. So now we can see for Abdel Nader, the average was 12. But again, this is bringing the last 3, 5, 7 because they were left in that data frame. So let's do this. Let's do it for the heirs. Heir 2 equals heir df dot, did I do dot? Yeah. Dot drop. We want to drop the last 3, last 5, last 7, season av, fp, and that's going to be axis equals 1 because we want to be dropping the columns. And then we want heir 2 dot transpose dot describe. Let's see what that gives us. So this should be giving us, we're dropping these, so we should only have the player and the heirs right across each run. So now we should be able to see what the average heir is for these players. So for Abdel Nader, our average heir was almost 7 points. Minimum was 2, maximum was 10. Brad Wanamaker, average heir of 0.3. Our maximum heir for him was only 1. That's pretty good. So that's a way we can kind of see the heir. We can do the same thing like it did for the compare df, which is showing what we're predicting. That's going to be what you want to do if you're looking at the different types of scores you're getting. But for this one, we were just doing the heirs, just kind of see how good we were on different players. And for better players, for higher variability players, they're naturally going to be harder to predict. So someone like Brad Wanamaker, like he's getting so much time off the bench, and he has a pretty consistent level, contribution level when he's in. Jump up to Chris Paul, that's almost a 2.1. Daniel Tice almost 2. Gallo's over 3. Dennis Schroeder's over 3. One more is 0. And this could also be if every single one of those players' data points were in the training data, it's going to be very good for them, right? OG Anunoby, or maybe they just didn't play. I don't know. We're not diving in too deep. That's not important here. I just wanted to show you guys how to break that out by player going the other direction. And if another way to do that, if we take a new data frame, analyzed data frame, we're going to do the heir df, and we're going to drop last 3, 5, 7, even average. So the exact same thing we just did up here. And then we're going to take a look at it, and now we're going to see it's going this way. And we're going to do this average, except we're also going to drop fp. So now we just have the heir. Another thing we can do is we can add a column. So analyze df average equals analyze df dot mean axis 1. So what that's going to do is it's going to calculate the mean. It's going to add in a new column. And now we have the average error for this. And we could do that for the points as well if we wanted. And that's pretty much all we're going to do today. There's a couple other ones here that, yeah, we're not doing that anymore because we don't have the fantasy points. But no big deal. That's all the core stuff I wanted to hit today. The main meat and potatoes of it is obviously getting some practice running through this process. Not just the air, obviously. You're probably more interested in getting the predictions for fantasy points and being able to look at those. That's the bulk of it. Some things we are going to be doing soon. We'll have one that will be going over how to take a model like this and actually apply it for, you know, a daily player list from FanDuel, DraftKings, etc. To take those players, create your features, create your labels that you don't have, obviously. We want to predict them. But take those features, we'll train a data set off of the big copy, and then we'll get our predictions off of the little copy that we have, right? So I'll have some things prepared for that, and that'll be a nice easy example on how to actually pull in the player list and run something like this several times, several iterations, and pull that data out. In the future, we'll be getting to compiling better data sets. I know you're all probably pretty tired of my last 3, 5, 7 here in season average, but it's nice and simple and easy to work through these examples with. Not a lot of room for data issues there. So we're going to be working on getting some better data sets. We're going to be looking at setting up and maintaining local databases, probably with SQLite because it's built into Python. You don't really need to do anything extra for that, because that's going to be a much better way to manage our data than just, you know, Excel spreadsheets saved in different folders. You can definitely do that as a backup, or if you're just an Excel fanboy, fangirl, go for it. I myself am not. I'd much rather get out into a database. So we'll start going over that stuff. We'll have several videos probably on SQLite, what it is, how to use it, etc. I've been looking in some interesting web scraping tools. We'll probably be doing a video or two on those to expose you guys to them if you'd like to use them. And that's all I got for right now. A huge shout out to the Patreon. I know I do it every video, but as you may have noticed, we're at a little bit better angle, probably a little bit better quality video of my wonderful face here down in the corner. That's thanks to the support from the Patreon folks. I was able to reinvest in a nice webcam. So instead of having my phone awkwardly propped up over here trying to catch me, you're now looking right at me on a pretty solid webcam mounted right on my monitor. So huge thank you, you guys. You guys are really making a difference in me being able to reinvest some money into this endeavor here. And thank you. So with that said, if you guys want to join the Patreon, check the link in the description. Get them for as little as $5 a month. Get in the private Discord server, blah, 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 blah. You know the drill. Check out the blog for this file, the Jupyter Notebook, and the sample data. I will see you guys next time. Thank you for the ongoing support. See ya.